I'm just finishing a shift, but I'll be ready to start the meeting in a minute. Good to see you guys. Hello. Fatima. Oh. Hello, everyone. Welcome. I'm just wondering if we are ready to rock and roll vis-a-vis going live. Hi, Dr. Howe. It's great to see you. Okay. Looks like we're live. So welcome, everyone, to the Collective Open Source Medical Innovations for COVID-19 monthly meeting. It's lovely to see all of you on board. I'm Dr. Philip Edgecombe, a MD PhD and diagnostic radiology resident at the University of British Columbia and co-founder of Cosmic. I'm thrilled to see the community come together again. We're going to have some very exciting updates. As per usual, we're going to hear in this meeting from our various open source teams, including Bubble Helmet, Gravity Ventilator, as well as the Oxygen Concentrator group. And we're joined by special guests from the SmithVent group. But before going any further, I just thought I would check in to see if Abhijit Pandari, one of our interim executive directors, could share a few words about why we are having these monthly meetings and what we're hoping to achieve during the meeting.
Well, since Cosmic started in March, we were very worried about the overall situation in terms of what's happening over the world. And soon we decided to develop some of the medical devices that can alleviate this crisis that we're going through. And as a result, from the month of March to now, we have developed about 5 different medical devices. And this monthly meeting is just kind of give the world an idea about what we're doing now, and perhaps join this venture and create an impact with us as well.
Totally. An opportunity to bring the community together, share our work with the world, and also highlight some of our fundraising and strategic priorities. So as I said earlier, we're very fortunate to be joined by Dr. Susanna Hall and Miss Astrid Harridan. I would be very grateful if you guys could just say a quick hello, and we'll come back to both of you later in the meeting for your feedback about how we're doing, as well as to learn about the SmithVent project. Are you guys on the call?
Sure. Hi, I'm Susanna Howe. I'm a professor of engineering at Smith College in Massachusetts in the US.
Hi everyone, I'm Astrid Lando, and I am a project management consultant at Pathways Canada. We're actually joined today by 2 additional members, Khalifa Clark and Beatrix Dalton.
Well, thank you to those members for joining. I think one of the purposes of our meetings is to kind of bring together the open source community. So that's really wonderful. Would those 2 members like to say a quick greeting?
Hi, I'm Khalifa. I'm with SmithVent. I am an R&D engineer at ConMed.
And then, hi, I'm Bea. I am not in engineering right now. I'm actually working for a United States senator, but I am also a member of SmithVent and here to represent us.
All right. Well, lovely to meet a good contingent of the SmithVent team. So what we normally do at our meetings is after our introduction and just before jumping into our main kind of agenda for the evening is we encourage everyone to join myself and everyone else at Cosmic in taking 3 deep breaths and to really focus on being present. So if you'll join me, that would be great. I'm just going to so just try to close your eyes or you know, do whatever you need to do, but just focus on being together with this group. So breathe in and breathe out. Leave all those concerns you have at the entrance to the virtual meeting. Breathe in and breathe out and breathe in and out. Awesome. That's really great. So now we're going to switch to, I'd encourage everyone to turn on their cameras, switch to gallery mode. And this is a really fun moment where we get to see who else is on the call and say hi to each other. I don't have my laptop running, so I'm hoping that Stanley might be able to help us take a group picture in gallery mode. Is that something that you can do for us, Stanley? And great to see everyone. Awesome. Hi, Abhijit. So Stanley, are you going to take a snap for us?
Doing that right now.
Okay. Give us the countdown.
3, 2, 1. I think
Perfect.
that should be good.
Okay. That is great. It's lovely to see everyone on the call. For the next part, we're going to jump into a update from the executive directors from Cosmic. Is Patrick Wilkie on? Can he give us a quick update about kind of ongoing efforts at Cosmic?
Hey, yeah. So I won't give the technical updates for the bubble helmet, oxygen concentrator, and GVent teams, but I just want to give a sort of broad overview of some of the other functions that the operations team has been doing at Cosmic. So this month, we've been working on a multilingual brochure that is in the process of being translated into other languages so that we can share that around the world with communities that we are connected with through our networks. And we have been connecting to various news outlets to share our story and to spread awareness around the existence of open source technologies that could increase the access to respiratory equipment for COVID-19. And we've been generating new ideas about how could we maintain Cosmic or this network of medical innovation after this current crisis and encapsulate what we've learned through the process so that other people can pick that up as a building block for the next crisis or for other connected challenges that we see. And so we kind of are still having ongoing discussions about how best to encapsulate that. But yeah, multilingual brochure, media outreach, and cosmic sustainability have been the key 3 themes this month.
Thank you so much for that update. And actually building on that, I've asked Peter to show off the multilingual brochure with the group and share a few words about the development and how the various Cosmic members can use it.
All right, I'm Peter from Media Relations, and this so far I've created a English version of the brochure to summarize the achievements and aspirations of Cosmic, so for international publication. So this will be, we are working on a workflow for translating this document and disseminating it. But so far we have an completed English version. So the ground base is done. And we made this to help with our outreach team and recruitment. And for that, I'll be handing it over to Eric Peterson, who is our recruitment lead.
Great, let's hear from Eric.
All right, so we're currently in recruitment. We're trying to contact UBC Student Newsletters to leverage university students. We're sort of experimenting with different methods right now, but we believe that the students would be interested in our cause.
Thanks so much, Eric. So appreciate that update, and you know, our scope and our ambitions are global, so it's really exciting to hear that we're going to be translating that and will allow us to reach other people in need, both as potential users of our designs and contributors as well. Okay, so I'm going to ask that we shift over to our project updates, and at the end of the project update, I will share a special announcement about a recent donation that we received. But let's talk first and foremost about the projects and the progress we've been making over the last month. So to kick things off, let's ask the gravity ventilator team to share an update.
All right, sure. Thanks, Phil. I'll just share screen here. Everyone see this okay?
Yeah, we see it.
All right, great. So here's a very quick update of what GVent's been up to over the past month. So for anyone who doesn't know much about GVent, the gravity ventilator project is essentially a very low-cost constant pressure ventilator project. It makes use of this novel water column pump design to generate constant pressures. And we believe it's a uniquely affordable to build this ventilator compared to other emergency ventilators. So some project updates over the last month. We've been continuing development on the platform and application levels of the control system. We have begun to put the test lung that we've purchased into use for testing the ventilation functions. And we've recently hardware locked our user interface design, meaning that there will be no more changes expected for how the user interface will look. Our upcoming plans in the next few weeks and in the new year are to design and build the entire system enclosure to hold all the valves as well as all the components of the user interface, finalize our software requirement specification, set that in stone and port it to our public GitHub, and to finish unit testing our application code. Once that's done, we will be able to call the application side complete. So that's it for our GVent update. For more information, you can visit gvent.ca.
Thanks, Alex. Can you tell us just a little bit more about the test lung? So, you know, what was the test lung that you purchased, and you know, is that something that you would recommend to other open source ventilator teams?
For sure. So we picked up a quick lung breather. It's a pretty robust industry standard of a test lung that's used in a lot of biomedical engineering departments. It's very useful for being able to change the compliance of the lungs when you're testing, and to be able to actually see if the pressures you're delivering change when there's a resistance. Certainly would recommend it for any emergency ventilator team. If you can get your hands on one or partner with another team that can lend you one, I think it's very crucial for testing.
Excellent. Thank you for that update, Alex. Bruce and the oxygen concentrator team, we'd love to hear from you guys next.
Okay, so the oxygen concentrator team is working on a low-cost oxygen concentrator that can be built close to the point of use with readily available materials and manufacturing skills. Oxygen concentrators have been around for half a century, but they haven't penetrated to a lot of rural areas in developing countries. And there has been a recognized need for oxygen supply that existed before COVID came along. And presumably it'll still be there after COVID has been wrestled to the ground. So I think this project has legs. You know, it has long-term utility, even if it's not, doesn't make a big difference for COVID. So where the project is right now is we got to the point where the components are assembled and pressure tested and ready to be loaded and run. Our biggest problem is that we don't have a home. We've been moving the workshop. The workspace has been moved several times, and we just found out we had to get everything out of there because the carpets are being steam cleaned, and besides it, the space won't be available after the end of December, and it's really difficult to work on something like this if we don't have a space where we can make a mess and make progress. So that's my appeal for today is if the powers that be could please find us a home. It's cold out there. But progress is being made, and we'll keep you updated. Be happy to answer questions if there are any.
Sure, why don't we open it up to questions? Does anyone have any questions about the oxygen concentrator group and their efforts?
Hi, Bruce. This is Ivan. About the space, I'd like to reach out to you and find out what your requirements are in terms of footprint, geographic location. I may have a line on some availability.
That would be excellent. Would you like to contact me through Slack or email?
If either email or cell phone. Who's got time to type these days? So maybe can I get your email quickly?
Okay, it's 1439 Devo. That's Delta Echo Victor Oscar.
Yeah.
At DCCNet, Delta Charlie November Echo Tango. Don't put a dot in between the DCC and the net.
Okay.
And then there's a .com at the end of it.
Got it.
I hope the bots don't get you.
Okay, 1439 Devo at dccnet.com. Got it.
Well done.
Well, let's hope that that works out. And Ivan, great to hear that you are one of the impersonations of the personification of the powers that be. So that could be a real update, real progress for our group. So thanks for offering that to the oxygen concentrator team. Okay, let's jump over to the bubble helmet crew and see what's happening there.
Hi, everyone. For the Bubble Helmet team, we have a little bit of background. The project is stemmed from the COVID-19 crisis in Italy, where they use a lot of the helmet CPAP. That is, the technology is not popular in North America. However, it is quite effective in managing respiratory distress for patients in large amount of volume, and therefore potentially reducing the use of critical care unit. And it improved the patient's outcome, as there are studies from North America that shows clinical efficacy of the helmet CPAP technology in patients with acute respiratory distress symptoms. And it also theoretically contain aerosols inside the bubble helmet while delivering patients the respiratory support, and therefore reducing the infection risk to the healthcare workers and the amount of viral load in the environment. So when COSMIC started, we want to create something similar in anticipations of the COVID-19 surge. So this is our design. It's very bare bone and much more simpler compared to the Italian versions. However, it works, and we have published our design as an open source, as well as in the peer-reviewed journal in the IEEE. So this is real life pictures of one of the doctors in VGH who's wearing our bubble helmet. So you can see it's a very simple a plastic hood with 2 ports that can be inflated and provide the positive pressure respiratory support for the patients. So I'm going to skip into our next step. So our next step is to generate good clinical trial data because in order for the project to be successful, we need the clinical data to support our effort. So at this moment, we had approval from Health Canada for from the interim orders to do clinical trials. And the next step is to agree on the format of the study design and clinical team who will run the study. And then we will apply for the ethics UBC institutions approval, and as well as fundraising for more manufacturing to manufacture more units. At the moment, we have 16 manufactured units. We are currently had submitted a resident doctor of BC application funding, and we are currently looking for more fundings and collaborations opportunity for the clinical trials and other potential study designs. And another major update for our team is that we have an interested distributor partner to adopt the bubble helmet. However, before they invest in our technology, they would like to do more market research survey to guarantee that there are a market and their money is not gonna go to waste. So we are looking for more clinicians for them to contact and talk to personally to support and provide opinions regarding our helmet CPAP technology. So if you do have some contacts, please send the emails to Monica, who is one of our team members who are organizing this outreach effort. And that's about it. Thank you so much.
Thank you for that, Fiona, and that call out to the powers that be. I am thrilled to hear about the progress, and I'm also thrilled to share that just yesterday we actually received a generous donation with a view to support the Bubble Helmet project, and that came from Gail Beatson. So we'll share some more details in the next month about how that funding is used, but I'd like to, if everyone could join in a quick clap to celebrate that generosity, that would be great. So I just wanted to highlight that one thing that stood out to Gail, and one of the reasons that she donated, is that she shared with me that the reason for donating is that I'm very impressed about how quickly the group assembled and worked together to channel ideas that should make a difference to the well-being of those most affected during the pandemic. And also I believe that there's a future for this work beyond the immediate crisis. So thank you so much, Gail, for your generosity. And we will soon see some more bubble helmets rolling off the production line and into our clinical trials. So thank you very much, Gail, for that. More details to come soon. So let's turn now to our special guests from SmithVent. I'm going to try something a bit different. As I introduce them, I have some special music. This is actually coming from Glenn, who is one of our team members. This is his band, Wicked Liquor, that recorded this music. So we've got the SmithVent, which is a group of Smith College alumni and friends who collaborated virtually, part-time, mostly evenings and on the weekends, to create a rapidly manufactured ventilator as part of the COVID-19 challenge. Susanna Ho joined the faculty of the Picker Engineering program in 2003 to develop the capstone design course, Design Clinic, which she continued to coordinate and teach. Her educational background and PE are in civil engineering, and she also has experience in mechanical and biomedical engineering through consulting work during summers and sabbaticals. We'll also be hearing from Astrid Landell, a 2015 Smith graduate of the Picker Engineering program. Since Smith, she continued her educational pursuits by earning her MBA in project management professional designation. She's currently a project manager consultant at Pathways to Education Canada, a not-for-profit organization that provides low-income students with the support needed to graduate high school and break the cycle of poverty. So there they are with the great intro music. So you guys can take it away, hopefully share your screen, and welcome.
Thank you so much. Let me share my screen. We're just going to walk through really quickly our master systems diagram. So as Philip alluded to, we took part in the COVID-19 challenge, which took place across the span of 10 weeks this summer. We had about 30 persons who were collaborating, all virtually. So we do understand that need for a workspace. We very luckily were able to use a location at Smith College, but only 4 members of our team had access to that location. The rest of us were remote. I'm in Canada. So we did have some logistics to happen. There was a lot of Zoom involved. We had basically a workbench with a camera facing down. Susanna was there and she was the hands and we were all the eyes. So let us just walk you through our master systems diagram. Susanna, do you want to go ahead?
Sure. So you can see on the screen there a picture of our CAD model of our final design, and you can see what it would look like in a hospital setting. And so that's sort of where we envision this product going. But on the next slide, we've got a master system diagram showing the general layout, and I won't talk you through the whole thing, but suffice it to say this is a pneumatic ventilator that leverages the compressed air and oxygen that's in a hospital. That was part of the competition guidelines, was that we could use the fact that there was compressed air and oxygen. And we have a variety of solenoid valves that control the flow, and then the air and the oxygen mix in a reservoir and then go into an inspiratory line, which is controlled with a proportional solenoid valve that truly is the sort of the brains of the controls of the operation. And then there are various pressure sensors and flow sensors running through that. And then it goes to the patient, and then comes back in an expiratory line through some more sensors, another solenoid valve, and then a manual PEEP valve. And we have a lot of electronics running the whole thing, largely running on an Arduino Mega. And we have a fairly large user interface touchscreen. I think it's a 10-inch Nexteon touchscreen for use. So if you look on the next slide, you can see the version that we actually built, the test bench. It does not look like the final enclosure because we wanted to have access to it as we were doing all of our testing. So this is designed to do both volume control mode and pressure support mode. And during the time frame of the competition, we did not have time to test the pressure support mode. So we only tested the volume control in the time frame we had. We didn't have access to a test lung, but we did a lot of other testing. I think we tested for about 35 different system requirements for the competition and another 6 that we added for ourselves. So it was a pretty rapid fire testing process. But of course, we know that there's a long way to go with this. There is a team actually at Smith College right now, a team of senior engineering students who are working on some additional work to this, including adding an oxygen sensor on the reservoir, taking the manual PEEP valve, the positive end expiratory pressure valve that we have that's outside the ventilator, and bringing it inside and making it digital. And we just got a quick lung, so we're able to do some testing and make sure that the pressure support mode that we've set up and the code that we've written actually works. And so that's sort of the plan of where things are right now with SmithVent. We're working closely with the folks from the COVID-19 Challenge who are planning to take this forward. They're looking for funding, and they're hoping ultimately to distribute in probably Africa and West Africa, because there's still very much a need for ventilators there. They're working with partners, particularly in Nigeria, to ultimately manufacture and distribute these. And Astrid has been in communication with a variety of groups around the world who are taking the SmithVent design, which is now all available on GrabCAD and up on Google Drive. So maybe Astrid can talk about that.
Yeah, so our entire design is completely open source. So you can find all our code, all our schematics, including our AutoCAD on tinyurl/SmithVent, so you guys can check us out there. Along with that, we've been trying to support any teams that had follow-up questions. So on our Gmail, we've gotten questions from Pakistan, Brazil, and India. So they are all trying to replicate our work, I think slightly differently, given their accessibility to the different things that we used here. So a lot seems to be happening with our design, and hopefully some of you all can also check it out and it may be of use to you.
Thank you very much. If I may, what would you say was one factor that contributed to your success in terms of recognition of the COVID-19 or the COVID-19 competition?
Bea, you want to take that one?
Yeah, so it was one of the factors that contributed to our success, and I think one thing that we had really found was it was our ability to work together and work together remotely. We started this project, I think, in April, correct me if I'm wrong. So it was right in the middle of the pandemic, and we didn't know how long it would be happening, what things would be, and we went in with the intention not to design a whole ventilator, but just to design a piece. So us knowing that we didn't have to do it perfectly, but we had the opportunity to fail, meant that we were able to kind of, everyone just gave it their all, and we tried our hardest, and it lucked out for us that it worked. But it was really the enthusiasm and motivation of everyone who made up our team. We ended up being a team of 30 people. And so everyone's different contributions are what made it so we were successful.
And I would say we were really attuned to the system requirements that were put out by the competition. There were a lot of entries to this competition that didn't adhere to some of those requirements because they were working on something themselves, or there were a variety of ventilators that really truly would not help support human life. And so we were trying very hard to make sure that whatever we were producing did meet those requirements, and we did enough testing to be able to show that. And that meant that we couldn't get as far along as some of the other ones potentially, but we were sure that what we were designing was going to meet what was required for specifically for COVID patients.
So a combination of realism and design work and specifications and teamwork. That's wonderful to hear. I think we have time for one question, and then we're going to have to wrap up the meeting, and we'll move into our informal meet and greet. So I'd love to open that up to the floor.
I have a quick question. Maybe not so quick, might be a really hard question. So yeah, you mentioned the kind of target deployment location being Africa and West Africa. Now, how to formulate the question. How are you localizing the design to be buildable and maintainable in those locations?
Yeah, that's a great question. So I think one reason for West Africa, and I should say that it's really the COVID-19 challenge folks who are taking this forward. We've submitted our design as part of this competition. We're not really continuing it other than having some student teams working on pieces of it, but really they're taking it forward. They picked Africa as a possibility for deployment in July when things were looking better in the US and in Canada. And now, of course, things are looking worse again. So it could be that we deploy these ventilators elsewhere as well. We designed this specifically to be leveraging commercially available components as much as possible with some 3D printed parts. So I think the big question will be, based on wherever this gets deployed, how accessible are all of those components? And any of them could get subbed out with DIY or other types of components. We did not optimize this design specifically for components that could be acquired around the world. So it may well be that the particular solenoid valves, for instance, that we use might not be the right ones depending on where people are building it. And I think that's one of the things that's getting tested by the various groups around the world that are trying to put in components. But we had specifications of what we were looking for these particular components, and somebody could sub in something else if they needed to. Does that answer your question, Patrick?
Yeah, it does. I think it's a hard question, and you kind of answered in a way that, so essentially they could find components that meet the specifications if they're more accessible.
Yeah. I mean, there have been some parts, as Astrid said, there have been some parts that have been hard to find exactly. And we, for the purposes of the competition, wanted to show functionality. So we tried to get components we could get as quickly as possible, which is not to say they're necessarily the best components. They're just the ones that we could get, and we could actually have them arrive in our shop fast enough to be able to put in place. And I think a longer term version of this design would really think about where you can get components reliably and at scale, and could also be optimizing for cost. And we didn't try to do that within the confines of the competition, but that's something that could certainly be thought about going forward.
Well, thank you for those comments. We are at time, but just before we wrap, I wanted to say a special thank you to Fatima, who's our co-lead for social media, and she has been the one that coordinated this meeting. So Fatima, if you could say a few words, and just if we could all thank Fatima too for making this work so flawlessly.
Thank you for everyone attending the Cosmic Medical Briefing tonight, and a big thank you to Dr. Howe and Astrid Lando, Beatrix Dalton, and Khalifa Clark for speaking tonight and informing us, talking about the great innovations that were discussed tonight. It was a pleasure to support the meeting tonight, and I'm looking forward to continue to support the innovations and designs that were introduced tonight.
Thank you. So social media is a big part of the success of any open source team, right? If an open source design is designed and no one uses it, I'm not sure if it really exists, right? From a bit of a philosophical perspective. So lovely to have your support there. So that brings us to an end to the formal part of the live stream. All of you are welcome to stick around. We're going to have an informal kind of themed breakout rooms after this for another 15 minutes. But thank you everyone for joining. And we'll see everyone next month. It's the third Thursday of every month. So you'll have to look at your calendars to figure out what day that is in January. But it will be coming up for sure. Okay, so I'm gonna kind of hand it back to Fatima, who's gonna guide us from here in terms of cutting the live stream and going into our breakout, into our breakout groups.
Okay, so I'm just going to break everyone up into the breakout rooms, and you guys can join the groups that you're assigned to.
Okay, and just as we go, the themed question for the first one is if you could just introduce yourself. We'll be 5 minutes in the breakout group, and then just comment on opportunities for collaboration in the open source community in your group, kind of things where it's worked and where it hasn't, and see what we can learn from